In the fifth lesson of Chapter 7 in the Pearson Geometry video series, 4 theorems are going to tell us how to set up proportions with random triangles and parallel lines. Theorem 7.5 is the side splitter theorem. It says a triangle segment parallel to the base divides the sides proportionately. So looking at the diagram, we can set up a proportion from the sides. So AM over MB is going to be equal to CN over NB. So this part over this part is equal to this part over this part, making them proportional. Theorem 7.6 is the midsegment theorem. The midsegment is the segment that connects the midpoints of the sides of a triangle. So this is a midpoint and this is a midpoint. You can see these are marked congruent. And this one says, if a segment joins the midpoints, then it's parallel to the base. So this is parallel to this. And it's half as long, which kind of makes sense, because if you think about our trapezoid theorem, you add these two bases together and then take half. Well, this base is 0. So that means we'd add 0 in this base and take half, which would just be half of this base. Or we could look at it like if this base is 2a, this one's going to be half, or a. All right, let's take a look at the corollary to the side splitter theorem, or corollary 7.5. And this one says, looking at the, if 3 parallel lines, so 1, 2, 3, are intercepted by 2 transversals, okay, so right here and right here, then they're proportional. Okay, so we can set up a proportion that says AB over BC is equal to DE over EF. So let's write that down. AB over BC is equal to DE over EF. Okay, and the last one, Theorem 7.7. This one is actually a little bit longer than would fit in the bubble. Okay, so this one says, if a ray bisects an angle, okay, so here's our ray bisecting this angle in a triangle, then it divides the opposite into 2 segments, the opposite side into 2 segments that are proportional to the sides. So this one over this one equals this one over this one. And we can go ahead and set that up as a proportion and say UX over XW is equal to UV over VW. Okay, so how are you going to know when to use which one of these? Well, if you have angle bisectors, you're going to use this one. If you have parallel lines, you're going to use this one. If you have a segment that's not necessarily a midsegment, then you'll use this one. And if you have a midsegment, then you're going to use this one. Okay, so let's take a look at example 1. In example 1, we want to find the value of y, which is right here. Okay, now the only way that we can find that is if we can set up a proportion, or if this is the midsegment. If it's the midsegment, then it'll be half of 30. Now the only way to know if it's the midsegment is to find out if UP is half of QP and if VR is half of QR. So we can set up a proportion, and when we set up a proportion, it's going to look like QS, okay, so 16, 12 plus 4, over x plus 2 is equal to QT, 9 plus 3, which is 12, over x. So this part of the side over this part, and this part of the side over this part. So we're falling back on Theorem 7.5. So we're going to say 16 over x plus 2 is equal to 12 over x. Okay, let's take a look at that. Okay, so if we solve that, we're going to cross multiply and say 16x is equal to 12 times x, which is 12x, plus 12 times 2, which is 24. And then we can subtract 12x from both sides. We'll have 4x is equal to 24, so x is equal to 6. Okay, so x is going to be equal to 6, so if x is equal to 6, then this right here is going to be 8, and 4 plus 8 is going to be 12. So we have 12 and 12. Over here, x is equal to 6, so we have 3 plus 6 is 9. So 9 and 9. So y is indeed a midsegment. So we can say that y is equal to half of 30, which equals 15. Okay, now the value of z. All right, so if we want to find the value of z, then we can use the fact that we have two proportional triangles. And we can set up a proportion that looks like 16 over z equals 24 over 30. Okay, so we're going to say 16 over z equals 24 over 30. So the leg over the base and the leg over the base. Okay, so let's take a look at what that looks like. So we have z times 24, which is 24z, and we have 16 times 30, and 16 times 30 equals 480, which means that z is going to be equal to 20. Okay, so y is equal to 15 and z is equal to 20. All right, let's flip this over on the back and take a look at some more examples. So taking a look at example 2, we have something that looks like our corollary. So we want to find x, and when we find x, we can say x over 60 is equal to 24 over 72. And x over 60 and 24 over 72, we can multiply 60 times 24 and then divide by 72, and we're going to get x is equal to 20. Okay, we can do the same thing with y. Here's y, so we're going to say y over 72 equals 24 over 60, and then 72 times 24 and then divided by 60 is going to give us a value for y of about 28.8. Okay, so both of those are coming from the corollary. All right, let's take a look at example 3. Example 3 looks difficult when you're first looking at it. The question is triangle MNL similar to triangle MKP? All right, just looking at it, it looks like it is. So in order to figure this out, we need to see if this side to this base is proportional to this side and this base. In order to do that, we're going to need to know what LP is. So we're going to use the corollary to figure this out. So we can say 7.5 over 10.5 is equal to 10 over x. And we can do that because these two sides are parallel. Okay, so if we figure that out, we're going to say 7.5x is equal to 10 times 10.5, which would be 105. And then when we divide both sides by 7.5, we're going to get x is equal to 14. Okay, so x is equal to 14. So now we can check our triangles. So we're going to say 7.5 over 10 is equal to 7.5 plus 10.5 over, that's not exactly the way I want to do that. Let me back up. We want 7.5 over this whole side. So 7.5 over 7.5 plus 10.5. And that needs to be equal to 10 over 10 plus 14. 10 over 10 plus 14. So let's take a look at how that would work out. So if we simplify, we're going to get 7.5 over 18 equals 10 over 24. So if these two work out to be the same, then that means that our triangles are proportional, therefore they're similar. So when we work this out, 7.5 times 24 is 180, and 10 times 18 is 180. So the answer then, let's see, and we also have a common angle here. So these two sides are proportional. So we've got two sides that are proportional and the included angle. So we would have to say, we'll come over here, sides are proportional, and angle M is equal to angle M. So therefore we have side, angle, side similarity. Okay, so answer to that is yes. Then down here, when we look at LKP and LPK, you can look at those and tell that they are not similar. Or congruent, because actually congruent is what they're asking. Okay, example 4. What is the value of x? Okay, so we have an angle bisector here. And using theorem 7.7, we can say that 12 over 3x minus 7 is equal to 18 over 3x plus 3. So this side over this side equals this side over this side. All right, so if we go ahead and set this up, we're going to get 54x minus 126, 18 times all of this, is equal to, and then 12 times all of this, so 36x plus 3, and then when we subtract 36x from both sides, we get 18x, and when we add 126 to both sides, we get 162, and so x is equal to 9. So what is the value of x? X is equal to 9. To find the values of GH and GK, we just plug that back in. So we're going to get 3 times 9 plus 3, which is 27 plus 3, which equals 30, which is the value for GH, and 3 times 9 minus 7, which is 27 minus 7, equals 20 for GK. All right, moving right along. We are up to our last example, and this one is another angle bisector one. So we want to say that AD over DC is equal to 10 over 16. So if AD equals x and AC equals 13, then DC is going to be 13 minus x. All right, so we've got x over 13 minus x is equal to 10 over 16. And then we want to multiply. So 16x is equal to 10 times 13 is 130 minus 10 times x is 10x. So we're going to add 10x to both sides and get 26x equals 130. And then dividing both sides by 26, we get x equals 5. All right, so we'll plug this back in. So AD is equal to x, which is equal to 5. And DC is equal to 13 minus x, which is 13 minus 5, which is going to be 8. And we are finished, and I will see you again in Chapter 8.